Look around you. We live in an age of wonders. Our pockets buzz with tiny supercomputers, we speak to machines, and sometimes they even understand us. This wave of innovation hasn't missed our oldest companion, the automobile. For over a century, cars were mostly mechanical beasts. You turned a wheel, pressed a pedal, simple, direct. But now, something profound is happening. Our cars are starting to think, they are becoming aware. This isn't science fiction anymore, it's the street you drive on every single day, transforming before your very eyes. The familiar purr of an engine now comes with a whisper of artificial intelligence. The vehicles rolling off assembly lines today are vastly different from their ancestors. They are packed with sensors, cameras, and intricate processors. These components are the eyes and ears of a new kind of intelligence. They see the lines on the road. They detect other cars, pedestrians, even a stray cat darting across your path. This isn't just about luxury, it's about a fundamental shift in how we interact with our vehicles and the world around us. We are moving from being solitary pilots to being partners with an increasingly capable co-pilot, one built from silicon and software. This digital co-pilot is changing the very nature of driving. Think about the sheer complexity of driving. It's a constant stream of decisions. Accelerate, brake, steer, check mirrors, anticipate. Humans are surprisingly good at it most of the time, but we get tired, we get distracted, our senses have limits. This is where the new generation of automotive technology steps in. It aims to augment our abilities to cover our blind spots, to react faster than humanly possible. It's a silent revolution, happening one car, one software update at a time, making our journeys safer and, in many ways, more fascinating. This transition isn't just about adding gadgets, it's about weaving a complex web of data and decision-making into the very fabric of our cars. The car is no longer just a mode of transport, it's becoming a sophisticated data processing hub on wheels. It learns, adapts, and communicates. The destination remains the same, but the journey, the experience of getting there, is undergoing a cosmic-scale transformation. We are truly at the dawn of intelligent wheels, a new era where our vehicles are becoming active participants in ensuring our safety and comfort on the road. So, what is this magic making our cars smarter? Much of it falls under the umbrella of ADAS. That stands for Advanced Driver Assistance Systems. It sounds technical, but the idea is simple. These are systems designed to help you, the driver. They act like an extra set of eyes, an extra pair of hands, sometimes even an extra brain. Think of them as your car's guardian angel, constantly watching out for potential dangers and helping you avoid them. They are the silent sentinels working tirelessly to make every trip a little bit safer for everyone. ADAS encompasses a wide array of features. You might already be familiar with some of them. Anti-lock braking systems, ABS, were in early form. Cruise control too. But modern ADAS goes much further. We're talking about systems like lane departure warnings, which gently nudge you if you start to drift. Blind spot detection, alerting you to vehicles you can't see. Automatic emergency braking, which can apply the brakes faster than you can react if it senses an imminent collision. These aren't just conveniences, they are life-saving technologies woven into the car's very being. The significance of ADAS in today's vehicles cannot be overstated. Road accidents, sadly, are a common tragedy. Human error plays a massive role in most of them. ADAS aims to mitigate that human error. By providing timely warnings or even taking temporary control in critical situations, these systems can prevent accidents before they happen. They are like having a vigilant co-pilot who never gets tired, never gets distracted, and has lightning-fast reflexes. This technology is a crucial stepping stone towards a future where roads are significantly safer for all users, pedestrians and drivers alike. These systems work through a symphony of sensors. Cameras provide visual information, much like our eyes. Radar can detect objects and their speeds, even in poor visibility. LiDAR, using laser light, creates a detailed 3D map of the surroundings. All this data streams into the car's central processing unit, its brain. This brain then interprets the information and decides on the appropriate action, whether it's a warning beep, a slight steering correction, or a full emergency stop. It's a complex dance of perception, processing, and action, all happening in fractions of a second. Now, how does ADAS get so smart? How does it learn to distinguish a pedestrian from a lamppost, or a safe gap in traffic from a dangerous one? The answer lies in artificial intelligence, specifically in a field called machine learning. Imagine trying to write traditional computer code for every single possible scenario a car might encounter on the road. It would be an impossible task. The real world is just too complex, too unpredictable. There are infinite variables, from weather conditions to the erratic behavior of other drivers or even animals. This is where AI performs its code magic. Instead of programmers writing explicit instructions for every conceivable event, they create AI models. These models are then trained using vast amounts of data. Think of it like showing a child millions of pictures of cats until it can reliably identify a cat, no matter its breed, color, or pose. Similarly, AI for ADAS is fed countless hours of driving footage, sensor data, and simulations. It learns to recognize patterns, to understand context, and to make incredibly sophisticated decisions based on this learning. The AI, in essence, helps write its own operational logic through this learning process, so AI doesn't literally sit down and type lines of code in the human sense. Rather, machine learning algorithms analyze data and generate complex mathematical models. These models are the core of the ADAS decision-making process. They are constantly refined and updated as they encounter new data and new situations. This means the code, the underlying logic, is always evolving, always improving, becoming more robust and more accurate. This adaptability is something traditional, handwritten code struggles to achieve on such a dynamic scale, especially in real-world, safety-critical applications like driving. The benefit of this AI-driven approach is immense. ADAS systems become better at predicting potential hazards. They can understand nuanced situations that would be incredibly difficult to define with simple rules. For example, an AI can learn the subtle cues that indicate a pedestrian might step onto the road, or that a car ahead is about to brake suddenly. This predictive power dramatically improves the functionality and reliability of ADAS, making these systems more effective at preventing accidents and making the driving experience smoother and less stressful for the human behind the wheel. The real-world examples of AI-powered ADAS are already transforming our daily drives. Adaptive cruise control, for instance, doesn't just maintain a set speed, it uses radar and cameras to keep a safe distance from the car in front, automatically slowing down and speeding up with the flow of traffic. Lane keeping assist actively steers the car to keep it centered in its lane, reducing driver fatigue on long journeys. Parking assist systems can now expertly maneuver your car into tight spots with minimal input from you. These are no longer features of high-end concept cars. They are becoming standard in many new vehicles. Consider systems like traffic sign recognition, where the car reads speed limit signs and reminds the driver, or even adjusts the adaptive cruise control accordingly. Or think about driver drowsiness detection, which monitors your eye movements and steering patterns, suggesting a brake if it senses you're getting tired. Tesla's Autopilot and GM's Super Cruise are prominent examples of highly advanced ADAS suites that leverage AI extensively, allowing for hands-free driving on certain highways. These systems are continuously learning from the collective experience of all vehicles using them, improving their capabilities with every mile driven globally. Looking ahead, the impact of AI-driven ADAS on driving safety and convenience will be even more profound. As AI models become more sophisticated and sensors become more powerful and cheaper, we'll see even more advanced features. Imagine cars that can communicate with each other and with city infrastructure to optimize traffic flow, reducing congestion and travel times. Picture vehicles that can navigate complex urban environments entirely on their own, offering true door-to-door autonomous transportation. This could revolutionize mobility for the elderly, the disabled, and those who cannot drive. The ultimate goal, for many, is fully autonomous driving level 5 autonomy, where the car handles all aspects of driving in all conditions, with no human intervention required. While we're not quite there yet in 2025, AI-driven ADAS is the critical pathway to that future. Each advancement, each improvement in how AI helps write the car's intelligence, brings us closer. The journey ahead promises not just safer roads and more convenient travel, but a fundamental reimagining of our relationship with our vehicles and our cities, all thanks to the quiet, ongoing revolution powered by artificial intelligence.